Assalamu alaikum everyone. This is the power transmission course and this is the last lecture on the mechanical design of transmission lines. In the last lecture we discussed about the sag and a brief overview what we have talked about in the last lecture. We started from the definition of sag. It is actually the distance between the horizontal line that is connecting the supporting points on the tower and the minimum point of the conductor, and it usually take the shape of catenary. And if the conductor is tightly stretched, then we can use the equations for the parabola to calculate the sag, and it can only be valid up till the value of sag which is 6% of the span, and if it is more than 6% of the span then the error is too much, which is up to 10%, so we cannot use that for the calculation of the sag. Then there were two main points. The tension at any point of the conductor actually act tangentially, and the horizontal component of the tension is constant throughout the conductor. And the last point was that the tension at the support point is actually equal to the horizontal tension. Then we related the sag and tension with each other, and we found out that they were inversely proportional. So if the sag is larger, then the tension will be smaller and vice versa. Then we calculated the formulas for the sag calculation. There were two cases. In the first case we have tower having equal heights, and in that case we tried to find out the moment of forces, one due to the weight that is acting perpendicularly downward, and then the second one is due to the tension, the horizontal tension. And both the moment of forces, if they are equal, then the whole transmission line will be in equilibrium. Due to weight, the moment of force was actually clockwise, and due to the tension it was anti-clockwise. So if these clockwise and anti-clockwise moment of force, if they are equal, then the transmission line will be in equilibrium. So what we have done, we have found out the two moment of forces and then we equate them, and after that we calculate a generic formula for the sag, in which we have W, which is the weight of the conductor, T is the tension, and X is actually the distance from the tower or the support points. And later for this particular case we used X is equal to L by 2, which is half of the span, and we have used it because the lowest point of the conductor is actually at the center of the total span of the conductor, so that's why we use X is equal to L by 2. And for Y is the perpendicular distance, so we have used S, which represents sag. Then in the second case we have towers at different heights, so the sag from each of the tower is different. So we calculated two sag, S1 and S2, one from the tower A, the other one from the tower B. And in the formula we know the weight of the conductor and tension, but we don't know the distances at which the sag will occur from the respective towers. So for that we have to calculate X1 and X2, and we calculated it by subtracting S1 from S2, and from there we got the value for X1, which is the distance from the tower A till the lowest point of the conductor, and from there we also calculated the value for X2. So if we know the values of X1 and X2, we can easily calculate the sag from either of the towers. Then we calculated the weight under the effect of wind and ice loading. So we have to add the weight of the ice as well as the weight that is introduced by the pressure of the wind. So the total weight is actually at an angle theta, is acting at an angle theta. It is not acting vertically downward. So what we have to do, if we have to find the total weight, we have to know the ice loading weight as well as the weight that is introduced by the blowing of wind. So for the weight of ice, we know that it is just the multiplication of density and volume of ice per unit length. For the calculation of volume, it is a cylinder. So what we have to do, we have to calculate the total volume of the conductor with ice loading and then subtract the volume of the conductor. We have done the same, and we calculated the volume of the cylinder, and then we subtracted the volume of conductor from the total volume. And for the calculation of wind force per unit length, again the weight that is introduced by the blowing wind, it is the multiplication of wind pressure per unit area into the projected area, not the actual area. In the case of the cylinder, the projected area is just a rectangle, because whenever the wind is actually blowing into the conductor is just acting as a rectangle to the wind. So we calculated the area of rectangle and then multiplied it with the wind pressure. So this was the last lecture, and if I just have to add few main points from the last lecture, so I will write it down here, main points. So we know that from the last lecture there is one weight that is due to wind pressure, the other one is due to ice loading and the weight of the conductor. So because of these two different weights, we have the total weight that is acting at an angle theta. And now if we have to find this angle theta, we can use the calculation for the right triangle. So tan theta is actually equal to the opposite over adjacent side, right? So it is opposite over adjacent side, or you can also write it as perpendicular over base, right? So if we have to calculate tan theta, it will be weight due to wind divided by weight of ice plus weight of conductor. So this is your tan theta, right? From here we can calculate the angle at which the conductor is actually slanting. Now if we have to find the sag in the conductor, we know the formula. S is the sag, total weight of the conductor, span divided by 8 into tension, right? So this is your total weight, span, torque, and this is your slant sag. Because we have an angle theta, this is not your vertical sag, this is your sag that is acting at an angle theta. Now what if we have to find the vertical sag? So this is your right triangle, right? So if I have to find this vertical sag, so this vertical sag will be cos theta is equal to sag vertical over the sag that is at an angle theta, right? So if you have to find the vertical sag, that is just the multiplication of the slant sag into cos theta. So these were the main points from the last lecture. If you have to find the angle at which the total weight is actually acting, then you just have to use the formula tan theta is equal to weight introduced by the wind pressure divided by the total weight that is acting vertically downward. And for the calculation of sag, you can use the total weight, but this particular sag is known as slant sag because it is using the weight, total weight, which is actually acting at an angle theta. And if you have to find the vertical sag, it is cos theta is equal to sag vertical over sag that is at an angle theta. So for the calculation of vertical sag, you just have to multiply cos theta, theta is the slant angle, with the sag that is calculated by this formula A. Now we will be moving on towards the examples that are related to the sag calculation. In the first example, we are given with a 132 kilovolt transmission line. The weight of the conductor is given, length of the span is given, ultimate strength is given, which will be used in the calculation of tension, and the safety factor is given. Now what we have to do, we have to find the height above the ground at which conductor should be supported, right? And ground clearance is given, which is equal to 10 meter. Now if we have two towers and we have a conductor with a particular sag, and what we have to find is the height above the ground at which conductor should be supported. So this is the point at which the conductor are supported. So we have to find this height, and if we know this value, this is sag, and we know the ground clearance, that will be the value that we have to find. So H is equal to sag plus ground clearance, right? So we have to find the height above the ground at which the conductor should be supported. So we will be starting from the calculation of sag. We know the formula of sag. It is equal to WL square 8T, right? So this is the weight of the conductor. This is span tension, right? Now for weight, we know that it is 680 kilogram per kilometer. Now if I will convert this into meter, so that will become 680 divided by 1000, and the unit will be kilogram per meter. So W will become 0.68 kilogram per meter. So now we know the value of weight. Span is given, which is equal to 260 meter, and for tension, the formula of tension is ultimate strength over safety factor. The ultimate strength is given, it is 3100 kilogram. So it is 3100 kilogram, and the safety factor is 2. So tension value is actually equal to 1550 kilogram. So now we know the weight of the conductor, we know the span, we know the tension. So the sag will be equal to 0.68 into 260 square over 8 into 1550, and the final value will be 3.7 meter. So this is your sag. Now we know the value of sag, it is 3.7 meter, and we also know the ground clearance, it is 10 meter. So what we had to find, height above the ground at which the conductor should be supported, and height is actually just the summation of sag and the ground clearance. So your height will be equal to 3.7 plus 10 meter, it is equal to 13.7 meter. So this was the first example. In the second example, again we are given with a transmission line having span 275 meter between level supports, right? By level supports, what does it mean? We have the towers which are having same height. The height of the towers are same. The conductor has an effective diameter of 1.96 centimeter. So this is your diameter, and weighs 0.865 kilogram per meter. So this is your weight, right? The ultimate strength is given. If the conductor has ice coating of radius 1.27 centimeter, I will assume it is equal to T, and is subjected to a wind pressure of 3.9 gram per centimeter square. So this is your wind pressure. Calculate the sag. For a safety factor of 2, we have to calculate sag weight of 1 cubic centimeter of ice is 0.91 gram. So now what we have to do, we have to find sag, right? We know the formula of the sag is WT L square over 8T. So now I'm not using the weight of the conductor, I'm using the total weight, which also include the weight introduced by the wind pressure and also by the ice loading, right? So this is WT, then we have to calculate the tension, but we know the span. So starting from, I will say this is equation A. So starting from the tension, we know the formula. It is ultimate strength over safety factor. So ultimate strength was 8060 over safety factor is 2. So the tension is 4030 kilogram. Now for span, L is equal to 275 meter. So the only thing that we don't know is the total weight. And from the formula we know that total weight is actually equal to weight of the conductor plus weight of the ice loading square plus weight introduced by the wind pressure, right? So we know this weight of the conductor, we have to find weight due to ice loading and weight due to wind pressure, right? So this weight is 0.865 kilogram per meter. Now for weight of the ice, first we have to find the volume, that is equal to pi T D plus T. So we have calculated this formula in the last lecture. We know the value of pi, it is 3.142. T is the thickness of ice, right? The thickness of ice loading, and it was 1.27 centimeter. So it is 1.27 into 10 raised to minus 2. This is for the centimeter, multiplied by diameter, it is 1.96 into 10 raised to minus 2 diameter of the conductor, plus again the ice loading thickness, it is 1.27 into 10 raised to minus 2, and the answer will be in meter cube because this is your volume. And after solving, it will become 0.04 into 3.23 10 raised to minus 2 meter cube, and volume of ice, it is equal to 1.292 into 10 raised to minus 3 meter cube. Now I will convert this volume into centimeter cube, and to convert it into centimeter cube I have to multiply it with 10 raised to 6. So it is 292 into 10 raised to minus 3 into 10 raised to 6 centimeter cube, and the volume will be 1292 centimeter cube. Now weight of ice, it is equal to density of ice into volume of ice. So the density of ice was 0.91 gram per centimeter cube. So that's why I have converted this volume into centimeter cube, 1292 centimeter cube. These will cancel out, and the weight of the ice will be 1.172 kilogram or 1172 gram. So this is the weight of ice. So now we calculated the weight of ice, which is 1172 gram. Now we have to find the weight introduced by the wind pressure, and for that we know that in the question wind pressure is given, pressure is equal to 3.9 gram per centimeter square, and for the weight value it will be pressure into projected area of the conductor. Now the pressure value is 3.9 gram per centimeter square, and the formula for the projected area is d plus 2t. So d is the diameter of the conductor and t is the ice loading thickness. So it will become 3.9 gram per centimeter square into 1.96 plus 2 into 1.27 centimeter. So the final value will be 17.55 gram per centimeter. So this is the weight introduced by the wind pressure. So now if I have to calculate it per unit length, because all the values are in per unit length, so it will be WW is equal to 17.55 gram per meter. If I have to calculate it into meter, I have to multiply it by 100, so it will become 1755 gram. And I will not write meter with the weight value because we know that this value is already in per unit length and the per unit length is meter. So this is the weight introduced by the wind pressure. So now what we had to find was the total weight. So this is 0.865 kilogram per meter. So this is already in per unit length. The weight of ice loading was 1172 gram plus the weight due to wind pressure was 1755 gram per meter. So the total weight, it will become WT is equal to, the formula was W plus WI square plus WW square. All the values are known, so it will become 0.865 plus 1172 square plus 1755 square. So the total weight will be 2.69 kilogram. Right? And the formula for the sag was S is equal to WT total weight L square over 8T. Weight is 2.69 into the length of span is 275 square divided by 8 into tension, which we found equal to 4030. So the sag is 6.3 meter. So this was the asked value. So now if in the question you are asked with the angle theta, the slant angle, so we know that tan theta is equal to WW over W plus WI, weight due to ice loading, weight due to wind pressure, weight of the conductor, and it will become 1755 over 0.865 plus 1.172 tan inverse. That will give you the value of theta 4075. And if you are also asked about the vertical sag, for the vertical sag the formula is the sag calculated into cos theta. It is 6.3 cos 40.75, 4.77 meter. So the vertical sag is less than the actual sag, which is 6.3 meter. So this was the second example in which we have to find the sag value if the ice loading and the wind pressure was also introduced. And what we have done, we have actually calculated the total weight that include the wind of the ice loading as well as the weight introduced by the wind pressure. And for that we have used the formulas that we already calculated for the volume of ice as well as for the weight introduced by the wind pressure. And if you are asked to find the angle theta at which the weight actually acting, so you have to use the formula tan theta is equal to ww over w plus wi, and for the vertical sag you just have to take the cosine of that particular angle theta and multiply it with the sag that you have already calculated. So this is known as vertical sag. In the last example we are going to solve the transmission line which is supported by two towers which are having unequal heights. And in this particular example we have two towers. The first one has a height of 30 meter and the second one is 90 meter. Now the horizontal distance between the two towers is 500 meters, so the span is 500 meters. If the tension in the conductor is 1600 kilograms, so the tension is given, it is 1600 kilogram. Find the minimum clearance of the conductor. Minimum clearance of the conductor is the sag and water and the clearance midway between the supports, right? And the second one is that we have to find the height of the conductor at the center of the transmission line. So we have to find at some particular point. For example, in this point we are given as P, so we have to find the height of this point P from the water, and we also have to find the minimum clearance between the water and the conductor. And we are given with the weight of the conductor which is 1.5 kilogram per meter. Bases of the tower can be considered at the water level. First we have to find these values. The height h, it can be easily calculated from the figure. The h value is, it is actually equal to s2 minus s1. So s2 is equal to 90 meter, s1 is equal to 30 meter, so it will be equal to 60 meter, right? The span is already given, it is L is equal to 500 meter, and that L, it is actually equal to x1 plus x2, right? It is equal to 500 meter. So now what we have to calculate, we have to calculate in the first part of the question minimum clearance of the conductor and water. So what we have to find, we have to find this value from point O to water. So we know the total value which is equal to 30 meter. So if we know this value which is actually the sag, so I will just subtract the sag from the height of tower A. That will give us the minimum clearance of the conductor and water. So first what should I do? I have to calculate the sag. So there are two sags because we have two different towers having different heights. So S1 is equal to W x1 square over 2t, and S2 is equal to W x2 square over 2t. So this x is actually the distance from the respective tower to the lowest point of the conductor. Now we already know h is equal to 60 meter, and h is equal to s2 minus s1 is equal to w x2 square over 2t minus w x1 square over 2t, and this value it is equal to 60, and w over 2t x2 square minus x1 square, w over 2t x2 minus x1, x2 plus x1, 60, and this value it is actually equal to 500 meter. So it will become 60 is equal to W over 2T into 500 x2 minus x1, and after solving it will become x2 minus x1 is equal to 60 into 2T over W into 500, right? We know the value of tension, which is 1600 kilogram, and for the weight we know it is 1.5 kilogram per meter, right? So 1.5 and x2 minus x1 will be 256 meter. Now we have two equations. First one is x1 plus x2 equal to 500, and the second one is this one, x2 minus x1 is equal to 256 meter. So if I will solve this equation, this will cancel out, and 2x2 is equal to 756 and x2 will be equal to 378 meter. From here we can calculate the value of x1. So x1 will be equal to 122 meter. So now what we had to find was this value. Suppose it is A, and first I will calculate this sag. So for the calculation of sag, S is equal to W x1 square over 2T. W is 1.5, x1 is 122 square over 2 into 1600. So S1 will be equal to, this is S1, because we are using distance from the tower A, it is 7 meter, right? So now we know that this value S, it is actually equal to 7 meter. Now if I have to find A, so A will be equal to 30 meter minus 7 meter. So A is equal to 23 meter. So this was the first part of the question, in which we had to find the minimum clearance of the conductor and the water. The second portion, we have to find the clearance midway between the supports. So we have to find at certain point. For example, in this case we have to find the clearance at point P, which is at distance x from point A. So weight of the conductor is same, and all the values, tension, weight and the height of the towers, they remain same. The only thing that is changing is the point at which we have to find the clearance. So we are going to find the clearance between water and conductor at point P. So now in part B we have to find clearance midway between the supports. So what we have assumed, there is a point P at distance x from 0. So assume we have a point P at distance x from O, right? In this figure we are assuming that we are going to find the clearance between water and conductor at point P, and we are supposing that this point P is actually at the center of the transmission line, and this point P is also at distance x from point O, which is the lowest point of the conductor. So now if I have to find this x, we know that x plus x1 is equal to 250 meter, right? Because x1 is a value that we already know. So this is the x1 we already know, and we are assuming that this particular point P, it is actually at the center of the transmission line. So addition of x1 and x, that will give you the value which is half of the total line span. So it is 500 meters. So x1 plus x will be equal to 250, right? So x plus x1, it is equal to 250 meter, and from there we can calculate x is equal to 250 minus x1, it is equal to 250 minus 122, and x will be equal to 128 meter, right? So now if I have to calculate the height of point P from O, so we already know that point O is actually at height A. So if I will calculate this difference of height between O and P, then I will add this height, that is, for example, this one. I will assume this is B. So if I will be able to calculate this height B, that is the height between the point O and the point P on the same conductor, then I will add this B in the height A. That will give you the clearance midway between the spots. Now to find the height B, that will be equal to Wx square over 2t 1.5 into 128 square 2 into 1600, and that will be 7.68 meter. So by using the value of x, which is the distance between the point O and P, I have calculated the height of this particular value B, which is the height between the lowest point of the conductor and midway of the span. So now I know the value of B, I already know the value of A. Now if I have to find the total clearance between the point P and the water, then I just have to add these two values A and B, right? So this particular value B, this is actually height of the transmission line at point P from point O, which is the minimum point of the conductor. So this point O is the minimum point P is actually the center point of the conductor. So we know that A is equal to 23 meter, which is the clearance of point O, clearance of point O from water, and for the clearance of point P, it will be A plus B. A is equal to 23 meter, B is equal to 7.68 meter, so it will be 31.68 meter. So this is the clearance of point P from the water surface. So this was the second part of the question. In the question we were asked to find the minimum clearance of the conductor and water, and in the second part it was mentioning that we have to find the clearance midway between the spots, right? So in the first case, we have calculated the value of sag. We know the height of the tower, so we just subtracted the sag from the height of the tower. That gave us the value of A, which is the clearance between the conductor and the water surface. Then in the second part of the question, we have to find the clearance at the midway between the spots. So what we have done, we have calculated the distance between the lowest point. We already know the clearance for that. So distance between the lowest point to the point which is at the center of the span, which is P, and after using the formula, I have calculated the height of that point P from point O, and then just added the value of B with A, and that gave us the clearance of point P from the water surface, that is 31.68 meter. So this was the last lecture on the mechanical design of the transmission line. We have covered 3 different topics. The first one was the economical sizing of the conductor. The second one is the string efficiency, and the last one is the sag calculation of the transmission line. So that's all for today. Thank you.